we're looking at our target 3.2 mastery learning objective. I can use angle measure to find arc measures and to find arc length, I should say. Let's fix that. And the area of a sector. Okay? So the first thing we need for arc length, remember an arc is a portion of a circumference. So when you are finding circumference, C equals 2 pi times r. Alright, circumference equals 2 pi r. So if you look at this example, find the circumference of the circle if the radius is 2.5 centimeters. Circumference equals 2 pi times 2.5. Just like before, we don't type pi in our calculator, so we're really just doing 2 times 2.5, which then gives us 5 pi centimeters. Okay. There's no squared or cubed. Circumference is a length, so just centimeters. Find the circumference of a circle if the diameter is 16 feet. I'm going to quickly draw this circle out. Right? We've seen our diameters before, right? The diameter is 16, which means the radius is 8. Right? We did that a lot in Unit 1, I think, right? So then circumference equals 2 pi times 8, which is 16 pi t. Okay? One thing you'll notice is if you're given the diameter, you don't even really have to do what we just did. Another way to find that circumference is d pi, diameter times pi. Example 4. Find the diameter and radius to the nearest hundredth if the circumference is 77.8. Let's do that. So let's do this. Circumference equals 2 pi r. Well, here I'm given that circumference. So 77.8 equals 2 pi times r. And I'm solving for r, which is over here. I need to get rid of the 2 pi. So I'm going to divide by 2 pi. In our calculator, which I don't have up yet. One thing to be very careful of as this is coming up, when you're typing this into the calculator, if you do 77.8 and then just divide it by 2 pi, it will divide by 2 and then multiply by pi, which is not what you want. So anytime you're typing anything like this in your calculator, make sure to put that 2 pi in parentheses, okay? A good rule of thumb is always put whatever is in your denominator in parentheses, and that way it really divides by both of those things. There it is. So in parentheses, I'm going to put 2 pi, and pi is next to h. And we get to the nearest hundredth, 12.38. And then our diameter is just twice that, so that's 24.76. Alright, just doubling 12.38. Alright, now we're going to look at how we find arc length. Oh, that's why it looked like there's so much room. Here's our arc length. Okay, so arc length is slightly different from arc measure. And I'm going to kind of reference this example 1. Right, yesterday we looked at how this 75-degree angle means the measure of this arc is 75 degrees. When we're going to look at arc length, we're going to talk about how, if I put a ruler to this arc, how long would it be, right? So arc length should be in inches, centimeters, feet, whatever, not degrees. Okay? So how we find arc length equals theta over 360 degrees. This is your central angle. Times 2 pi r, or d pi, if you'd like to use that. Okay. Really what this is, right, if we have the central angle divided by 360, this 360 is a whole circle. So really, this is a fraction that represents what part of the circle we're finding. And then we multiply that fraction by the whole circumference, right? So we're just taking a portion, a fraction of the circumference. All right, so let's look at an example. Find the length of zy and arc zy in terms of pi. So, the length, again, equals the angle over 360 degrees times 2 pi r. This angle is 75 over 360 times 2 pi times 4. Okay? And again, we can just type this in our calculator and don't type the pi in because I want it in terms of pi, right? That means I still have a pi in my answer. That's not what I wanted to do. Alright, here we go. Okay. And move this over. Fabulous. Okay, so we have 75 divided by 360 times 2 times 4, right? Again, we don't type that pi in the calculator. But we will write pi here. And usually, when we write it, that pi goes with the numerator. So it's like 5 pi over 3 inches. It's not wrong if you put 5/3 pi. It's just not our standard notation. For these problems, don't be afraid of fractions. You'll get fractions a lot because you have this fraction at the beginning. Not every time, but a lot of times you'll have a fraction. Okay? So now this example, or part B, right, also finding zy. This part here. Right, again, zy, so it's the shortest path. And so then length equals theta over 360 times 2 pi r. Again, our angle is 130 degrees this time. And again, we can use the fact that this is 2r. Right, I don't have to cut it in half and then multiply it by 2 again. I can just throw that 10 in and say, okay, yeah, 2r is 10, because that's the same thing as the diameter. And then we can just type this in our calculator. So we have 130 over 360 times 10. And you get 65 pi over 18 centimeters. Right. All right, our example 2 is more like a circumference problem. A car tire has a 14-inch radius. How far has the car traveled if the tire rotated after 5? How far has the car traveled? This doesn't make any sense, this question. Car traveled, just get rid of this part, after 5 revolutions of the wheel. Or if the tire rotated 5 times. I think I was trying to say 2 things at the same time. How far has the car traveled after 5 revolutions of the wheel? So let's draw our car tire. Okay. It has a 14-inch radius. Well, if I go around once, That's the circumference. Right? If I go 5 revolutions, that's going to be 5 times the circumference. So that's going to equal 5 times 2 pi r. It's going to be 5 times 2 pi times 14. In this word problem, I am going to type pi in my calculator. Okay, with word problems, type pi in your calculator. It doesn't say leave in terms of pi. Okay, so 5 times 2 times pi times 14. And you get about 40, we'll round up, 440 inches. Okay. So if your tire rotates 5 times, you'll travel 440 inches forward. All right, go ahead, turn the page. The next thing we're going to look at is sector area. So what is the area of a circle? Again, we've looked at this already. We looked at it in KC1. But the area for a circle, area equals pi r squared. There's no fun, oh, if I'm given the diameter, then I can just throw the diameter in. That doesn't work here, okay? So this one you have, for area, you have to have the radius. A sector is a portion of the area. And I always think of it as a pizza slice. Okay, a slice of pizza is in the shape of a sector. Okay. Sector area is very similar, the formula, to arc length. The only difference is, right, I'm finding the portion of the area instead of a portion of the circumference. So it's still that angle over 360, right? Find that fraction, but this time multiply it by the area instead of multiplying it by the circumference. Okay? So we really set these problems up the same way. Find the area of the sector, right? Well, area equals theta over 360. Times pi r squared. Okay. So 60 over 360 times pi times 10 squared. Forgot the pi. Right. But again, throw it in your calculator. So the solving of these two things are exactly the same, right? Again, it's just this last formula that's different. 60 divided by 360 times 10 squared. Right? Again, we don't type pi in a calculator if it wants it in terms of pi. And that's 50 pi over 3 inches squared. Right? It's an area, so now it's squared. Or before it was like a length, not squared. Part B, same thing, right? Area equals theta over 360 times pi r squared equals 315 over 360 times pi r 14 squared. I'm just going to plug that in, 315 by 360 times 14 squared. Right? And I'm not going to plug in pi because it wants it in terms of pi. And that's 343 pi over 2 inches squared. So we'll be looking at those two formulas a lot tomorrow. And then let's look at a few examples. So example 4, a round pizza with a 16-inch diameter is cut into 6 congruent slices. What is the area of one slice in terms of pie? So here's my pizza. It's cut into 6 congruent slices. Pretend those are all the same size. It has a 16-inch diameter. The double apostrophe means inches, right? So, right, that's what that means, 16-inch. Okay. So, again, usually we do area equals theta over 360 times pi r squared. We're going to change that slightly for this problem. I don't know what the angle of one slice is, and there's not really much point in solving for it. Instead, I'm going to do, I want one slice out of 6 slices. So I'm just changing that, how I find that fraction, that portion that I multiply by the area. Okay? So 1/6 times pi. Now our r, if the diameter is 16, the radius is 8. Again, I want this in terms of pi. So I'm just going to have 30 over 3 inches, right? So sometimes how you find that fraction can be different. Okay? All right, example 5, a gardener is setting up a sprinkler system. The sprinkler rotates through an angle and projects water 30 feet. If the gardener wants the sprinkler to cover 1,000 feet squared of the lawn, what angle does he have to set it to? Okay, so here's my sprinkler, and it's going to project water 30 feet and cover some angle, right? And the area that it wants to cover is 1,000 feet squared. Okay? So if I'm thinking about area equals theta over 360 times pi r squared, right? What do I know? Well, I know the area already, right? That's the 1,000 equals theta over 360 times pi times 30 squared. I'm going to simplify this side. Nothing's in terms of pi, so I'm going to type pi into my calculator. So I have pi times 30 squared, and I want to divide by this 360. And I get 7.85 times theta, right? I just type these things in my calculator. Right? That 360 still has to be in the division. You could do 1 over 360 times this times this. This is slightly faster typing it in your calculator. It's up to you. Okay? Now I'm just solving. And then we have 1,000 divided by 7.85. And we get that our angle, with these problems we should round up. So I'm going to round up to at least probably about 128 degrees. I should round up, because if I round down, it's not going to quite cover 1,000 feet, right? It's just going to cut it off. So be careful with your problems. Sometimes the problem tells you should round up or down. that is it. I'll see you guys tomorrow.